In Chapter 9, we are going to be moving on to comparing two populations, so comparing one population against another population, versus where we were in Chapters 7 and 8, where we were just looking at one population. So like I said, we're going to be moving on to two populations at a time. In the first section here, 9.1, we're going to be looking at comparing two population proportions. So remember, that's percentages. So we are going to be looking at comparing two populations. We're doing a hypothesis test first, and then we'll move on to confidence intervals. So we're going to take a look here at a z-test for two population proportions. And to make sure we have an idea here what's going on, we've got two populations of interest, and we're going to consider their sample sizes. They might be different. So our first population, we're going to call sample size n sub 1, and our second population is going to have a sample of size n sub 2. And then from each of those populations, we are going to take a sample. The sample proportion, sometimes we're going to use P1 hat, other times we're going to use P1 prime. It just depends on the textbook. The calculator uses something different than the textbook, so we're going to look at both of those notations. And then the sample proportion for population 2 is either going to be P2 hat or P2 prime. Okay, so what we're doing this time is, instead of the one population case that we looked at in Chapter 7, where we looked at a hypothesis that our population proportion was equal to some specified percentage, this time our null hypothesis is going to test that the population proportion for population A, or population 1, is equal to the population proportion for population B, or population 2. Okay, so I'm calling this A and this B. Okay, we still have three alternatives to choose from. So that's the nice part, is that we're going to be consistent here. The first possibility is that the proportion for A just differs from the proportion for B. So that's going to be our two-tailed case. Another possible alternative is that the proportion for A is greater than the proportion for B, which would be right-tailed. And then our last choice for our alternative is that the proportion for A is less than the proportion for B, and that would be left-tailed. Okay, so I already mentioned that this is going to be a z-test, so we need that z-test statistic. Although realistically, pretty much from here on out, we're going to be using the calculators exclusively for finding our test statistic, but I still want to give it to you by hand so you know what it is. So the test statistic z is going to be P sub A prime, so that's the sample proportion from population A, minus P sub B prime, so that's the sample proportion from population B, divided by the square root of P sub P, which we will define in a second, times 1 minus P sub P, times 1 over n sub A, plus 1 over n sub B. And I mentioned we were going to define P sub P. P sub P is what we call the pooled proportion. So what we're essentially doing is we are grouping together our number of successes from both population A and population B, and grouping together our total number of trials from population A and from population B. And calculating a pooled proportion. So you have the number of successes in A plus the number of successes in B over the number of trials in A plus the number of trials in B, and that's what gives us this P sub P value. Okay, so again, I wanted you to have that, but we are going to be doing these calculations using the graphing calculator to make things go a little bit faster. So next page, we're going to go ahead and look at an example. Okay, so this example says that researchers conducted a study to find out if there's a difference in the use of e-readers by different age groups. And it says here, randomly selected participants were divided into 2 age groups. So we've got a 16 to 29-year-old group. And in that group, we're told that 7% of the 628 that were surveyed would use e-readers. And then we have another group that looks like it's 30 plus years old. And in that group, we are told that 11% out of 2,309 participants use e-readers. And so what we want to do is we want to test the claim to see if there's a difference in the use of e-readers by age group. And so let's start with the first step of doing a hypothesis test, which is to state our significance level, alpha. We are told to use a 2% significance level, so alpha is 0.02. And our next step is going to be to state our hypotheses. So our null hypothesis, if you remember from the previous page, was that the proportion for the first population was equal to the proportion for the second. So I'm going to call this P young equals P old for our younger group and our older group. And the alternative that we are testing here is just looking for a difference. So that's going to be a two-tailed. P young is just not equal to P old. Okay, so two-tailed test. All right, next thing we're going to need to do is calculate our test statistic. In order to do that, though, I'm going to take us to the calculator. We're going to do this part by hand. We have to do a couple things first. And that is we are going to need here the number of successes for each group. So we have the sample sizes, right? Sample size here was 628 and here was 2,309, but we need the number of successes. So 7% of those 628 would be our X for the young group. So 0.07 times 628 gives us about 44 individuals for the yes group, meaning yes that they use e-readers. And then our count for number of successes for the older group was 11% of 2,309, which gives us 254. And we do have to round those to whole number counts because remember, these are number of people. If you put in a decimal, the calculator is going to give you an error, okay? All right, so we said we're going to do this test using the calculator. We're going to go to the stat key and we're going to scroll over to tests. And down to option 6, we are doing a 2 proportion Z test. So hit enter. And so what it's asking for here is X1. So this is the number of successes from your first group. That's our 44. And then the number of people surveyed in that first group were 628. X2, this is our number of successes in the older group. That's 254 out of 2,309. We are choosing a two-tailed alternative. And then we're going to scroll down to calculate and just hit enter. And you'll notice there it gives us our test statistic, Z, right here at the top, is negative 2.94 if we round to 2 decimal places. And this is nice because it gives us step 4, which is our p-value. It gives us our p-value there right away as well. And it is already taking into account that this is a two-tailed alternative. So we don't need to do anything to that p-value. It's just 0.0033. All right, so we've got our test statistic, we've got our p-value. We're going to combine steps 5 and 6. That's where we make our decision. So remember, our decision rule says if the p-value is less than or equal to alpha, we reject the null hypothesis. So we're asking, is our p-value of 0.0033 less than alpha, which was 0.02? Clearly that's a yes. And so we are going to reject the null hypothesis. Okay. And then the last step is just to summarize our conclusion, which we're going to start off stating our significance level. So at the 2% significance level, the data provides sufficient evidence to conclude, there is a difference, right? We are rejecting the null that they're the same and concluding the alternative that there's a difference in the use of e-readers for the two age groups. Okay, so that would be our complete hypothesis test.